Okay, so in order for us to be able to communicate about this, it's important that we understand what the vocabulary means. So the first thing to understand is what exactly is a quadratic function. A quadratic function is any function that can be written in this form: f of x equal to ax squared plus bx plus c. Okay, so it's basically that simple. But a cannot equal 0. And we can think about why that would be a problem. If a equals 0, then 0 times x squared equals 0, and then we're just left with bx plus c. Well, you should recognize a function that looks like that. That would be a linear function or a constant function. So that right away we don't want that to be a quadratic function. So a cannot equal 0, but b and c can equal any number. And this is the definition you should put on your notes. The next term we need to define is parabola. A parabola is the graph of any quadratic function. So no matter what a, b, or c is, any quadratic function is going to look something of this form, kind of U-shaped that way, or it could be facing down like that. So for your definition, you can just write graph of a quadratic function. Graph of a quadratic function. And it'd be a good idea to have a picture there as well. Okay, the next word is axis of symmetry. The axis of symmetry is a vertical line that divides the parabola into congruent halves. So let me show you an example. If we had this parabola right here, the axis of symmetry would be a vertical line straight down the middle, assuming that this would be the same as this, a mirrored reflection of that. There's a few definitions we could give for vertex, but the one that's going to be probably the most useful is the point on the parabola where the parabola changes direction. So that's direction. Okay. So let me show you an example. If we had this parabola right here, notice it's climbing, it's going up and up and up and up and up and up. But at some point, let's say right about there, the parabola starts to change direction and go down. Let me pick a different color here. So that point, that single point right there, and we'll have an x and a y, is our vertex. The words maximum and minimum, I think, are pretty self-intuitive. The vertex will always be either a maximum or a minimum of our parabola. So, for example, if the parabola is opening down, if we see it like that, then our vertex, which would be up at the top, would be the maximum. So it's the maximum y value that our quadratic function reaches. Or if our parabola is opening upwards, the vertex will be the lowest point here, and that would be the minimum y value that our parabola reaches. Okay, this discriminant is kind of a weird word, but it comes from our quadratic formula. If you remember the quadratic formula, it's a method of finding the roots of our parabola or our quadratic function. A negative b plus or minus the square root of b squared minus 4ac. You don't have to write this down right now, but I'm just trying to see if you remember this. Divided by 2a. So that would give us two roots or two zeros of our quadratic function. Well, the discriminant is the part inside the radical here. So what you should write down for discriminant is b squared minus 4ac. And as we'll see later, the discriminant actually gives us some important information about the roots of our quadratic function. Okay, so next is the x-intercept, which is the point on our parabola that crosses the x-axis. So I'll allow you to write that in words, but I'm just going to show you a picture. So if we had a parabola, we would have an x-intercept here, so it's crossing the x-axis, and an x-intercept there. It's also important to note that for the x-intercept, y equals 0 always. And we'll actually use that later to solve for the x-intercept. Then the last vocabulary term is y-intercept. You should be familiar with this, but again, it's just the point on the parabola that crosses the y-axis. So again, you should write that in words, but I will draw a picture. So if I drew this parabola, our y-intercept would be would be this point right here. And what's important to note is for the y-intercept, x always equals 0. So you can use that to actually solve for the y-intercept, as we'll see later. And that's all the vocabulary terms.